Pointers. Just hearing this word makes many beginners nervous. You have probably heard things like pointers are the hardest topic in C++. If you don't understand pointers, you will never master C++. But here's the truth. Pointers are not difficult, they are just misunderstood. And in this episode, I will explain pointers using real-life analogies, memory visualizations, animations, and live coding so that by the end you will finally understand what a pointer really is, how memory works, and why pointers are one of the most powerful features of C++. So, hello everybody, welcome to C++. As we say, master the code, build the future, and let's begin with this episode. So, can a computer find your data without an address? Imagine ordering food online. The delivery partner doesn't know you personally. They use your address to find you. Computers work the same way. Memory holds thousands of variables, and the CPU needs an address to reach any specific piece of data. So the question arises, why addresses matter? Addresses let programs locate variables precisely and quickly. And what pointers do is that pointers store the location where data lives, not the data itself. So consequences without address, programs cannot locate variables reliably. Data sharing and dynamic structures break down, and efficient memory management becomes impossible. So, simply, without address, you can't work. Every variable, everything has its location, and its location is the address of it. So, key takeaway for you is pointers do not store data, they store the location where the data exists. Coming, everything around us uses addresses. Like addresses are a universal locating system. From house number to door number to cell positions, they let us find things immediately without scanning everything. So computer memory uses the same pattern. Every stored value has a unique address that identifies where it lives. So if house is there, house number gives the exact location in a city. Book is there, then self number specifies that which volume is stored. Hospital bed number locate a patient quickly. Student, a roll number justifies the identity for the student in the class. And for the hotel, the room number identifies the exact room. And for parking lot, slot number where a vehicle is parked. Simply, there are lots of examples. Everything requires an address for it. So pointers are simply variables that remember memory addresses. Coming next, where does a variable live? So when a program runs, its variables are stored in RAM, which is random access memory. So RAM is partitioned into many small locations. Each location stores data and has a unique numerical addresses. So the CPU reads and writes data by referencing these addresses directly. So memory characteristics. Each storage cell holds data. Each cell has a unique address. Cells are independently accessible. The analogy behind this is that thinking of RAM as an apartment building. So each room considered as memory cell stores something and has a room number that's the address of it. So each room memory cell has an address for it. So variables have two important properties. First is value, the data itself, and second is memory address, the location that identifies that value. So here every variable in memory has both a value and an address. For example, an integer variable age might hold the value 20 and reside at memory address, let's say 104. The CPU uses the address to find and operate on the value. So address is a must and the value at which that address is also must. So important observation, the value answers what, the address answers where. Both are essential to work with data in memory. So every variable always has both a value and an address. Coming next, inside the computer's memory, a table view. Memory table has addresses with stored values shown in rows, and CPU lookup like neon highlights shows addresses, lookup and read values. So memory locations are identified by their numerical addresses. The CPU or program supplies an address to read or write the corresponding value. So addresses are fixed for a location, while stored values can change over time. So observation is that addresses are unique and stable for a location. Values stored in those addresses can change, and the CPU operates on addresses internally to access data. And for the visual thing, think of the address as a mailbox number and the value as the letter inside. So you must know the mailbox number. To get the letter, we have to go there and get to the mailbox in order to get the letter. So imagine programming without addresses. Many essential programming tasks depend on knowing where data is stored. Without address, you cannot easily share or modify variables. So across functions, create dynamic data structures or manage memory efficiently. Pointers solve this by allowing one variable to hold the address of another, enabling indirect access and shared references. Here, if game development is here, pointers allow fast object linking and efficient resource management for real-time systems. And like databases, pointers underpin record linking in memory caches and low-level index structures. And for compiler and operating systems and compiler rely on pointers for memory management and symbol resolution. So without address, nothing can work, especially in technical and language-based work for C++ language and also for other work, also coding world. Everywhere address is required, address is the main thing there, and also here also. So pointers connect different parts of a program through memory addresses. So what is a pointer? A pointer is a special variable whose value is a memory address rather than the direct data. So by storing the address, a pointer gives you indirect access to another variable's value. So you can read, modify that value by following the address stored in the pointer. So key characteristics. So hold an address, not the full data. Enables indirect access and modification. Essential for dynamic memory and advanced structures. Improves program efficiency when used correctly. So next steps are, we will next cover address operator, pointer declaration, initialization and dereference, but always with memory diagrams first to build intuition before syntax. So a pointer is just a variable whose value is a memory address. So the address operator. So now that we know every variable has a memory address, the next question is how can we access the address in C++? So C++ provides a special operator called the address operator. So purpose of it is that it returns the memory address of a variable. It lets you locate where a variable is stored in RAM and forms the foundation for using pointers. Let's say this is int age 20, cout and age, which means and is address of age, and simply means address address, and after its age return, then it is address of age. So expected output here will be 104 because in the memory we have saved it as 104. Means it is saved with 104 address. Let's it as an example. So the AND operator does not return the value, it returns the memory address. So important thing is addresses vary each run and by machine. So the printed number is the location of the variable in RAM, not the data stored there. So introducing pointer variables. A normal variable stores a value, for example age equals to 20. But a pointer variable stores the memory address where another variable resides. This enables indirect access and manipulation. So if let's say normal variable, we take age equal to 20. But for the pointer variable, we will say it stores an address 104 points to the variable that contains that value 20. You understood? So normal variable stores value, but pointer variable stores address. So a pointer is simply another variable whose value is an address. So how do we declare a pointer? So in C++, the asterisk, the star here, I say star sometimes, it's asterisk, is used to declare pointer variables. So the declaration creates the pointer object but doesn't make it point anywhere yet. Let's say this is the syntax, the data type first, then asterisk, and then the pointer name. Here as an example, int star ptr is a pointer here. Explanation of it is like int is a pointer which will point to an integer, star is marks the variable as a pointer, and ptr is the pointer variable name. So declaration only creates the pointer but it doesn't assign an address. So best practices are to choose meaningful names such as age ptr, marks ptr or salary ptr to clarify that it is a pointer. So initializing a pointer. So initializing a pointer. So after declaration, assign a pointer the address of an existing variable using the address operator, which is AND. So step 1 is to create variable like this and then get address of it like this that evaluates to the address. Let's say if example is 104. So step 3 is to store address in the pointer like int star ptr is equal to and age. So now the ptr contains the 104 as address of it. So the pointer value is equal to memory address. The pointer stores the location, not the actual numerical value of the pointed variable. So understanding pointer memory. Pointers are variable too. They occur They occupy memory and therefore have their own addresses. So there are two layers, the pointer storage and the storage it points to. Example, memory snapshot. If a variable is age with the value 20 and has address 104, and another PTR which has value 104 and address 200. So these are different. So key points are both variable and pointers have addresses. Pointers store other variables' addresses as their values. So the memory diagram helps visualize these relationships clearly. If you see here, the value 20 is given here for a variable age with address this 104, and a variable ptr is here whose value in pointer is 104 with an address of 200 of it. So the ptr points to address 104, which is here. So dereferencing a pointer. So once a pointer stores an address, use the dereference operator to read or modify the value located at that address. Example, int age 20, int dereferencing operator ptr is equal to and age. Cout asterisk ptr, which is output, is equal to 20, which is the value of age. So and give the address, star follows the address and retrieves the data stored there, and the same star symbol means pointer during declaration and dereference during usage. So declaration asterisk means pointer and usage asterisk means dereference, which is access value also. So modifying value through pointer and summary, like pointers can both read and modify the original variable. Changing pointer updates the memory cell at the stored address. The original variable changes directly with no copies created. So if an example is int age equals to 20, int star ptr is equal to end of age and star ptr is equal to 50, here benefits are change values in place, efficient for large data arrays and function arguments, and essential for dynamic memory and system level programming. So the summary of pointer basics is every variable has a memory address and pointer and returns the address, asterisk declares or dereferences. A pointer stores a memory address and itself occupies memory, and using pointers you can access and modify original values directly. So in the next episode we will explore multiple pointers and much more things also, which is this episode only, just the part of this episode. So this can multiple pointers point to the same variable. So answer is yes. A single variable can have more than one pointer referencing it. Each pointer simply stores the variable's memory address, so multiple pointers can hold the same address and therefore access the same storage location. Let's say we take int age equals to 20. We take int asterisk ptr1 equals to and age, asterisk ptr2 also equals to and age. So both have the same address of age. So in the memory view here you can see here is ptr1, here is ptr2, both are indicating to age variable only. So both 1 and 2 contain identical addresses and point to same memory block labeled age. So changing value via one pointer is immediately visible through the other. This is important thing. The change when a value is changed via one pointer, it is immediately visible through the other also. Like a real life analogy, to give you an example, is if one house, a variable, can be reached by multiple people using the same postal address. So the memory address there, everyone arrives at the same place. it is like used like that. So multiple pointers can point to one variable because they all store the same memory address. Coming next, passing pointers to functions. So by default, function receives copies of values. Passing a pointer gives the function the variable's address instead of copy. So the function can then dereference the pointer to read or modify the original variable, enabling in-place updates. Whether if it's a call site or it's a inside the function or it's a effect, you pass the variable address, the function receives the pointer parameter, and changes persist after the function returns. So the advantages are no unnecessary copying, faster execution, persistent changes, ideal for large data structure, records, arrays, dynamic memory. Some common applications include updating records, editing arrays, swapping values, and managing dynamic memory. So the passing pointer lets function work directly with original data. Prefer this for in-place modification and performance. Coming next, we have swapping two numbers using pointers. So swapping values is a classic pointer use case. If you pass value by copy, the function swaps only. Local copies and original remain unchanged. So passing pointer lets the function access and swap the original memory locations. So the question arises, why pointers? The swap function receives addresses, dereferences them, and exchanges the contents at those addresses. So the originals are updated directly. So typical pattern here is word swap int asterisk a int asterisk b int t is equal to asterisk a is equal to b asterisk b is equal to 3 t, which means this three lines of code here inside this swap function is to swap the values. So where it is used? It is used in sorting algorithms, in-place transformations, low-level data processing, commonly used pointer-based swaps for efficiency. So pointers enable swapping originals. Think of exchanging originals rather than photocopies. So let me show you this question in VS Code also. So let me write the boilerplate one. Oh, I put square bracket by mistake. Here are curly bracket always. So the question we are doing is to swap the pointers. So 1 minute. So inside int main, let me take int x equal to 10, int y equal to 20. That much is it's okay. And then we will take another function name swap number with 10 with x and value of x and y. Let me create the function void swap numbers, where I will say int star x int star y, like this. So I will say int temp equals to star x, and in the next line I will say star x equals to star y, and in the third line here I will say star y is equal to temp. So this is how the all of the work here is swapped. All of the variables value given are swapped. So after taking them, we will simply say cout x and y. Here also I will include and at both because we are passing addresses of the values. So that's it. Our code is done. So now when I run the code, so here you can see the value comes 20 in 10, whereas the value we gave is 10 in 20 for x and y. So for the value of x it gave 20 and for the value of y it gave 10. So that's how our question is done. We have successfully swapped these values. So I hope you understood the question. If there is any doubt, you can ask me directly in the comment section. Next we have is null ptr keyword. So the null ptr keyword is a modern C++ introducer that null ptr to explicitly represent a pointer that points to nothing. So simply use null ptr instead of leaving pointers uninitialized or assigning 0 because it is type safe and prevents ambiguity between integer and pointer values. So definition is null ptr indicates an empty pointer that does not refer to any object or memory address. And the benefits of it are prevents accidental memory access, simplifies debugging, and aligns with modern C++ best practices. So for the use case, we initialize unused pointers like int start ptr equal to null ptr with checks before dereferencing. So if ptr, then it is safe to use star p. Here it's easy, it won't form any error or won't give any garbage value, at least if we assign it to null ptr. You can also see here the good choice is null ptr, simple way, easy to go. Whereas if you don't assign the value, it just danger here, danger and danger undefined, may crash, corruption can happen, anything can happen, and so difficult to go through it. So the suggested thing is to assign it as null ptr. Coming next, why uninitialized pointer are dangerous? Because an uninitialized pointer may contain a leftover or random memory address. So dereferencing such a pointer can cause program crashes, corrupted data, undefined behavior, or security vulnerabilities. That is one of the most common cause of elusive works. So these are the potential consequences it can harm, and the best practice is that initialize pointer immediately, use null ptr when no target exists, and never dereference a pointer without verifying it points to valid memory. Coming next, pointer safety rules. You have to always initialize because initialize pointers at declaration like int star p is equal to null ptr or int value or int star p is equal to end value. So always initialize. Prefer null PTR. Use null PTR for clarity and type safety instead of 0 or null. Never dereference a null PTR. So always check truthiness if P safe or else handle null. So never dereference a null PTR. Also know your target. Be certain of the object's lifetime and ownership before using the pointer. So some real world uses of pointers are like operating systems, game engines and graphics, database systems, robotics and embedded systems, AI and ML libraries, compilers and browsers. So without pointers, many modern systems would be inefficient or practically impossible. So they enable direct low-level control of memory. Very important. So So if it's done, now are you ready for the pointer arithmetic? So you should now be comfortable with memory addresses, address operator, pointer declaration, initialization, dereferencing. So multiple pointers to the same variable. So the passing pointers to the function and null PTR and pointer safety rules are done till now. So the key takeaways till now are pointers are variables that store memory addresses. With that mental model, you can reason about access, ownership, and lifetime. Next, we have pointer arithmetic, arrays and pointers, memory traversal, and accessing arrays using pointers, practical techniques for traversing and manipulating memory. So coming next, we have pointer arithmetic moving through memory. So pointers do more than hold addresses, they can move from one memory location to another. So this movement is called pointer arithmetic. So rather than changing the data stored in memory, pointer arithmetic changes the address that the pointer contains. So the common operations like increment, decrement, move forward or backward, these are solved here. So why this matters is because pointer movement enables efficient traversal of contiguous memory such as arrays and buffers. Coming next, understanding pointer increment. So consider an integer stored consecutively in memory. So if each int occupies 4 bytes, so incrementing an int pointer like ptr++ moves it from address 100 to 104 to 8 to 12 to 16. So the pointer advances to the next element of that type. So not just the next numeric address. The key mechanic like the compiler adds size of type to the pointer when you write ptr, and for the programmer view you write ptr++ but the compiler generates address arithmetic behind the scenes. Coming next, pointer arithmetic with different data types. So pointer movement depends on the size of the data type. The pointer references the same pointer instruction advances by different byte counts. Whether it's char, int, double, each of them has different byte size, but all are used in pointer. If it's in char, that the pointer address increases by 1. If it's int, then by 4 it increases, and if it's double, by 8 it increases. Understand how the bytes are important. So pointer arithmetic is type aware. The pointer type determines the step size, a foundational rule when navigating memory safety and predictability. Coming next, arrays and pointers. So arrays and pointers are intimately related. The array name decays to the address of its first element. So elements are laid out contiguously, which makes pointer arithmetic an efficient way to traverse arrays. If arrays as address is taken, the array name acts like a pointer to element 0. And for the memory layout, for example, array is this stored at this addresses. So ARR points to address 100 and that's always correct. So accessing array elements using pointers. So accessing array elements using pointers. So you can access array elements two equivalent ways. Firstly, indexing like ARR2, intuitive, common in high-level code, or pointer arithmetic like star ARR plus 2, explicit address computation using pointer addition. So they reference the same memory like ARR0 is equal to star ARR, ARR1 is equal to star ARR plus 1, ARR2 is equal to star ARR plus 2. So use whichever expresses intent more clearly in your context. So coming next, traversing an array using pointers. So pointers traversal visits each element sequentially by updating the pointer and dereferencing it like start, read, start PTR is equal to PTR, read next, repeat. This pattern is compact and maps directly to memory access. To initialize, we will use int star p is equal to ARR, which points to first element. To read and advance, we use star p, then p plus plus to move to the next element. And to terminate, we use stop when t is equal to ARR plus n or after reading all elements. So benefits of this includes cleaner logic for some algorithms, potential performance advantages in low-level code, and a natural fit for pointer-based data structures. So let me show you the code for this question in VS Code. So here hashtag include using namespace standard return 0. So this is the boilerplate work for this, and we are doing. Firstly, I will explain you with pointer arithmetic so that you will understand traversal work more easily. So int ARR5 and let it equals to 10, 20, 30, 40, 50. So after this we will say int star ptr is equal to ARR, cout asterisk ptr, and after this we will say end of line. So the star ptr is the pointer here, and after this we will say ptr plus plus, which is done through pointer arithmetic. Now let me copy this and again print this ptr, and now again ptr plus plus to again increase the value of this. And now let me again copy this like here, and in the last here in the next line, this is much we have to do for the code here. So now when I run the code, simply what it says is 10, 20 and 30, which is the first 1, 2 and 3 first three values. So the cout ptr at the starting refers to the 10. Then when ptr plus plus done, then it moves to the next element with next address. If it's int here, then it will move 4 bytes ahead, and that will come to 20. So here at this line, in this ptr 20 is printed, and for this 30 gets printed. I hope you understood. Coming now, let me show you traversing array using pointers. So hashtag include IOStream using namespace standard int main return 0. So inside this boilerplate, firstly let me take int ARR of 5, which is equal to 2, 4, 6, 8, 10. So these are 5 values I have taken. Now I will say int star ptr is equal to ARR here. Int star, or you can say asterisk. And after this, we will take a for loop in which I will say for int I equal to 0, I less than 5, I plus plus. Because we know that here we have only 5 values, 5 elements, because here 2, 4, 6, 8, 10 is here. So as simple as that. So inside this for loop, we will simply say cout and after that we will simply just ptr plus plus, so that int continues to print the further ones also. So running the code, we get all of the 5 numbers printed in the console. Commenting all of it. And now coming back to our presentation. So comparing indexes and pointer traversal. So both indexing and pointer traversal reach the same data. Choice depend on clarity and performance needs and context. So indexed based traversal, simple and readable, common in application code, clear intent for element positions. Or if it's pointer based traversal, then we work with row addresses, often used in system and performance sensitive code, and enables elegant idioms for iterators and C APIs. So conclusion here is choose the approach that best balances readability and control for your problem domain. So different techniques, same destination. So the summary and next steps here are: today you learned how pointers move through memory, pointer arithmetic, increment and decrement, type dependent movement, arrays as contiguous memory, pointer based access, traversal patterns. Mastering these concepts prepares you for dynamic memory, link structures, and low level optimizations. So key takeaway for this episode are: pointers allow efficient movement through memory. Arithmetic changes addresses, not the stored values. And coming up next is common pointer mistakes, real world use cases, and interview questions. Some homework is also there for you. So understand memory and pointers because your greatest programming tool it is. So next section will cover pitfall safety and practical exercises. So common mistakes beginner make. So pointers are powerful tools in C++, but small mistake can cause crashes. Undefined behaviors and long debugging sessions. This slide highlights the most frequent beginner errors that consequences and concise best practices to avoid them. A very common mistake beginners do is uninitialize pointers. They just don't uninitialize it. So they don't initialize it and it becomes uninitialized. So declaring a pointer without assigning an address often leads to unpredictable behavior. Always initialize pointer immediately. Another common mistake is dereferencing null PTR. So accessing memory through null PTR causes runtime crashes. Use checks or smart pointers to guard dereference operations. Or we can say confusing and star. So the address operator and yields addresses and the dereference operator, which is this, accesses the pointed to value. So people mix up and logical errors becomes there. Or sometimes we take incorrect addresses, assigning the wrong addresses forms incorrect addresses. So pointers are variables too. So pointers occupy memory and must be managed like any other variable. They can be copied, reassigned and invalidated. So the common results for all of you is wrong output, program crash, undefined behavior, difficult debugging. So coming next, pointers in real world software development. So pointers are foundational in system level and performance critical code. They enable direct memory access, low overhead data structures and efficient resource management. So all essential in high performance domains. So operating systems, game development, database system, compilers are all real world software development examples. So AI and high performance computing, embedded systems, networking. So many high performing applications depend on pointers for speed and memory efficiency. So pointers is the very main and key aspect for everything. So pointers versus normal variables. So distinguish pointers from normal variable is critical. One holds data directly, other holds address that receive data. So understanding the difference clarifies how memory is accessed and modified. So for a normal variable, we stores data like the number 25 and access directly. Used for everyday values when indirection isn't needed. But pointer variables are used to store a memory address that accesses data indirectly via dereference. It is used for memory management and advanced patterns. Simply a variable holds a value directly in its own memory location, while a pointer stores the memory address of a value, not the value itself. So in memory, the 42 takes 1008 value and is just there. But if pointer the value 2008 directed to the value 42's address, so in memory it takes another address 2008. So pointer is the PTR is the pointer name. It stores the address 2008. The value 42 lives at that address. Quick revision. Pointer journey till now is what is memory, memory addresses, pointer declaration and initialization, dereference and modify, pointer arithmetic and arrays, passing pointers to functions. Up next, some interview and viva questions. Core concepts are what is pointer, why do we use pointer, what is AND operator, what is asterisk operator. Some behavior and safety questions for you are what is null PTR, what is pointer arithmetic, how do arrays relate to pointers. And some edge cases questions like what happens with an uninitialized pointer, why pass pointer to functions, and difference between variable and pointer. So understanding the concept is more valuable than memorizing definitions. An interview tip for all of you is that always explain with a quick memory sketch, show addresses, pointer variables, and how dereference maps to actual values. Use short code snippets to demonstrate behavior when possible. Coming next, some practice problem and mini challenges for all of you. If you think you are in beginner level, you should try these 4 questions. And do tell me if you want the solution for any of these. I will surely provide you. If it's intermediate, you want to try after beginner doing beginner questions, you try to do these pointer questions. And the mini challenge, it is like gold wrapped in a question. That's all. So store marks of 5 students in an array, use only pointer to display marks, compute total and average, and protect against out of bound access. So these are hand-on exercises, fast-track understanding. Solve these progressively. Start with basic pointer manipulation, then move to array traversal and pointer-only solutions. So, episode summary. This episode connected foundational concepts to practical skills. The flow below represents the learning path you followed and key takeaways to retain for interviews and real-world coding. So, memory and addresses. So every variable occupies memory at an address. And pointer variables. So addresses of pointer, operator and pointer declarations link names to address. Star pointer, which is also dereferenced to access arrays and applications. Array decays to pointer, pointer power system levels and high performance code. So key takeaway for you is every variable has an address. Pointer stores the addresses. Dereferencing excessive values. Pointer arithmetic helps traversal. So arrays and pointers are closely connected. So closing thought, pointers are not inherently difficult. Mastering them requires practice, visualization, and careful attention to ownership and lifetime. I have done my part. You do your part. Try to do these questions and make pointers more in your knowledge because they are very important and important to understand. So congratulations, you have completed a core module on pointers. The foundation prepares you for structured composite data types and more advanced memory layouts. Keep practicing to cement these skills. Next episode we have structures in C++, where we will studying what are structures, why structures needed, and all of these things. And every expert once struggled. The difference is persistence. Keep building, keep experimenting, master the core, build the future. And at the last, I would like to say congratulations, you have completed one of the most important topics in C++. Today you learned memory addresses, pointer variable, address, dereference operator, null pointer, pointer arithmetic, pointer with arrays. So remember, pointers aren't memorizing syntax, they are about understanding how memory works. So once memory becomes clear, advanced topics like dynamic memory allocation, data structure, STL, and even operating system becomes much easier to understand. In the next episode, we will learn structure in C++, where we will discover how to group related data into a single user-defined type and take another step toward object-oriented programming. So if this video helped you, like, share, and subscribe to ShivCore so you don't miss the next episode. Until then, master the core, build the future. Signing off, ShivCore.